In this video, we are going to look at the derivatives of exponential functions and logarithmic functions of base other than e. So this exponential function has some base b to the power of x, and this log function is not the natural logarithmic function, but log of any base b. And what is given here are the derivatives of such functions. Now we're going to use them in the following problems. In the first one, you have y equals x cubed times 3 to the power of x. So as you can see, one is a power function and another one is an exponential function, and there is a product of them. So when you're taking this derivative, you have to use the product rule. So I'm going to keep the first function as is and multiply it with the derivative of the second, which is itself times ln 3 plus 3 to the power of x times 3x squared. Okay, so I can combine and see how to write this. So x squared and 3 to the power of x are common factors. If I want, I can take them out. And then I have x ln 3 plus 3 as my answer. Okay. So again here, when I take this derivative, I'm going to apply the chain rule here. The derivative of 2 to the power of whatever this is itself, right, times ln of the base. But here, there was not just x in the exponent, but there is some other function of it. So I had to apply the chain rule, and the derivative of 3 plus sine x is just cosine x. So that is my final answer. And if you want to write it a little bit better, you can always write it like so. Okay. Here I'm going to apply the quotient rule. So when I apply the quotient rule, I take the denominator up, multiply it by the derivative of the numerator minus numerator times the derivative of the denominator all over denominator the whole squared. Okay, so then I distribute 2 to the power of x times 2 to the power of x. So when you multiply two exponents, you add them. So x plus x will become 2x. So this will become 2 to the power of 2x ln 2 plus 2 to the power of x ln 2 minus 2 to the power of 2x ln 2 all over 2 to the power of x plus 1 the whole square. So that means that this and this are going to get cancelled away, leaving the final answer as 2 to the power of x ln 2 over 2 to the power of x plus 1 the whole square. So now we have a log function. So again, I have to use chain rule here. So I bring this constant multiple down, and I know that for taking the derivative of a log function, I do 1 over whatever the argument is, and then there is an ln of the base that goes to the denominator. But here I apply the chain rule, and I had to take the derivative of the inner function, which is 2x. So my final answer is 8x over x squared minus 1 ln 3. So here I had to use the product rule. So I take this derivative, I keep the first function as is, I take the derivative of the second function times the derivative of the inner function, which is 2 cosine x negative sine x, plus ln cosine squared x times negative sine x. Okay, so let's see how we can simplify this. So I'm canceling a bunch of stuff. So this cosine cancels with one of the cosine, this cosine and this cosine goes away. So that means what I have here is -2 sine x minus sine x ln cosine squared x is my final answer. So here I have to do the third order derivative. So this is what I'm going to do. I'm going to write it down first so that I can do my first order derivative using the product rule. So I have x squared times 1 over x plus ln x times 2x. Now this can be reduced to x plus 2x ln x. So when I take the second order derivative, the derivative of x is just 1. And then I apply the product rule here. So I have 2x times 1 over x plus ln x times 2. So if I simplify this, I get 1 plus 2 plus 2 ln x, which can be written as 3 plus 2 ln x. Now, when I take the third order derivative, the derivative of 3 is just 0. So my final answer will be 2 over x. Here I'm going to use logarithmic differentiation. So the first thing I'm going to do is take ln on both sides. So then this x can become the coefficient. I take the derivative now. I use the product rule followed by the chain rule. Okay. Simplify this. Move the y to the other side. And that's your final answer.